Hello, my name is Vishrut Patel and I'm here to show you how to balance a chemical equation using algebra. Okay, let's begin. So the first step I typically take is I take a time to look at the equation. Looking at the equation, we see that the reactants we have are iron 2, H plus, and NO3, while the products we have are iron 3, NO, and H2O. One thing that clearly stands out is that the iron changes. It gains an electron. Keeping that in mind, we infer that this is an oxidation reduction reaction. Okay. So the next step that we take is we label every single coefficient with a variable. So let's do that right now. Let's label the first with an A, second with a B, third with a C, fourth, now we're moving on to the products with a D, fifth with an E, and the last one, the sixth, with an F. Step 2. Next, we would look for the relationships between the reactants and the products. Okay, we'll see that there's one Fe on the reactant side and one Fe on the product side. So basically we just take the variable that corresponds with that Fe. So there's 1A equal to 1D. And again, this is because we have 1, so the A is only 1, and the D is only 1 since we only have 1. Okay. Moving on to hydrogen, we see that there's one H on the left, so we do B, which corresponds to the hydrogen. Looking to the right, this time we actually see that there's two H's. So the corresponding letter F gets 2, so we do 2F. Next, let's move on to the N, nitrogen. We see that there's one C to the left, and we see that there's one E on the right. Lastly, the last thing we have to do is oxygen. We see that there's 3 oxygens, since it's O3, so we do 3C. But there's a special case for oxygen. This time we actually see that oxygen is divided among 2 compounds. So how do we do this? First, let's look at the first compound. We see that there's 1 oxygen. So basically we would do what we normally do. We'd write 1E. But now we also see that there's oxygen on the H2O, but there's only 1 oxygen. So using this, we would do plus the next oxygen. So this would be plus 1S since there's only 1 oxygen. Okay. So now we have some relationships set up between the products and the reactants. We can see that N is already balanced by just looking at the equation and looking at the relationship. C is equal to D. C is equal to E. Yeah, that's balanced. A is equal to D also looks balanced, but the one thing that I noted earlier is that the charge changes. So let's not mess with this until we're done with the equation. Okay. We want to keep nitrogen constant, so we need to begin with oxygen. So working with oxygen, let's work with F. We see that we have one F right here, and let's work with F and E, sorry. We have one F right here and one E right here. So we have 1 plus 1, which is equal to 2 oxygens total for the products. While on the other side, we actually have 3 oxygens over here for C, since we have 3C is equal to E to the F, E plus F. So let's multiply F by 2, 2F plus E again, we're still keeping E, is equal to 3C. And we chose F instead of E because we wanted to keep nitrogen constant since it's already balanced. Okay. So now that we see this, we see that we have 2 F's, which will give you 2 oxygens now. You get 1 oxygen from the NO, so we have 3 right here, and now we have 3. Oxygen is balanced. Next, we see that we have 4 hydrogens. Sorry, we have 2 hydrogens. No, actually we have 4. Sorry, once again. I should have labeled earlier, but we multiplied this by 2. And this 2 is from the earlier equation when we multiplied 2 by F. Okay. So looking at this, we see that we have 2 times H2, which will give you a total of 4 hydrogens on the product side. So now we have to get 4 hydrogens on the reactant side. And to simply do this, we would replace B with 4 times B, since B is equal to 2F. Okay, since what we implemented right here was 2F times 2, which will give you 4F. And since B is equal to 2F, we would need 1B. We would need 4 B's. To balance it out. Since there'd be 4 H's right here, 4 H's right here. Okay, so let's put a 4 right here. Okay, so far we have the hydrogen balanced, and we have the oxygen balanced. We also know that we came in with the nitrogen balanced. Well, so what's left? Just the iron. Okay, so one thing we want to look back at is, remember the one thing that we inferred at the beginning. When we first looked at the equation, we saw that the charges differed. And the one thing that happens when you're undergoing a reaction is that the charges of the products is equal to the charges of the reactants that you originally started out with. So looking at this, we see that we have 4 hydrogens. So we have 4 electrons right here, 4 times 1, plus 2 right here. So we have a total of 6 for now. While in the products, we have 3 right here from the Fe plus 3, plus, actually that's just 3. Sorry. Yeah, that stays with 3. So we have 3 E's right here, electrons, E standing for electrons. While we're over here, we have 6. Okay. So, the question is, how exactly are we going to balance the electrons now? Looking at this, we're trying to get a common denominator. And in order to get the common denominator, we can see that the Fe's over here, we have 3, and we have 6 over here. And the common denominator between 6 and 3 would be 6, but that wouldn't work. Because we would have to do the next common denominator, which would be 12. So in order to obtain 12 electrons on both sides, the nearest common denominator, we would do 4 Fe's. Okay, so 4 Fe's will give you a total of 4 times 3, which will equal to 12 E's for your products. Now, the thing is, we have to achieve the 12 E's on the reactant side. So in order to get this, we already know we have 4 right here. 4 E's right here. I'm not including these 6 E's right here, but I'm saying we have 4 just from the hydrogen. Okay, and we have a total of 12 on this side, since we have 4 times 3 is equal to 12E. So subtract this 12E by the 4E, and we're left with we still making up for the other 8 electrons. So the only other place on the reactant side where we do have electrons is the Fe2+. So in order to get 8 electrons, we would multiply this by 4. And I'm saying this because 4 times the 2 electrons gives you 8. So now, let me do this on the bottom so you can see this clearly. We have 8 electrons from the Fe over here, 8 times 2, plus the 4 electrons from the hydrogen right here, equal to the 4 times 3 electrons to give you a total of 12 right here, and a total of 12 right here. So 12 is equal to 12. Now that we have each compound, each element balanced, and we have the electrons balanced, we are officially done with this problem. So as a final balance, we'd have 4 Fe2 plus 4H plus the NO3, actually we left the same, so we just write NO3, yielding for our products 4, which we added in right here in order to obtain the correct amount of electrons. E3 plus the NO, which we never touched since nitrogen was already balanced, plus the final H2O, which we have 2 in the front, which we balanced earlier too. Looking at this, let's review and make sure that we have everything balanced. Okay, we have 4 Fe's over here. 4 Fe's over here. We have 4 hydrogens here. And 4 hydrogens here, because the H2 times 2 will give you 4. We have 3 oxygens over here. Actually, let's go to nitrogen. We have 1 nitrogen here. And we have 1 nitrogen here. Lastly, let's look at the oxygens. We have 3 oxygens over here, the reactants. And we have 1 oxygen here, plus 2 times this oxygen, which will give you 2 right here, plus 1. 3 is equal to 3. So oxygens are also met. Next, let's look at the charges. We have 4 times 2, which will give you a total charge of 8 electrons, plus 4 times 1, which will give you another 4 electrons, which will give you 12 electrons over here. And let's look at this side. We have 4 times the 3 electron over here, so we'd get 12 electrons over here. And now this is balanced. So we have correctly balanced a chemical equation using algebra. Thank you.